a look at factoring with diamond problems. First, a review. In a quadratic, we have this parent function y equals x squared. And the shape of that graph is a parabola where it changes direction at 0, 0. In previous units, we've looked at where if we have numbers inside the parentheses, the minus 3 right here, that would shift our function to the right 3, and the plus 1 would shift it up 1. And so if I ask you what is the vertex of this following shifted function, you would say, well, it's 3, 1. So we've done a bunch of examples with this before and looked at patterns. And if it's in vertex form, it's always going to be the opposite of what's inside the parentheses for your x value. And then the y value is going to be the k value, which is the number on the outside. It will be the same. So the vertex of this new shifted function if it goes to the right 3 and up 1, will be 3, 1. Then we looked at factored form. So the factors help us find the x-intercepts of the quadratic, and we learned that the factors are going to be the opposite of what's in the parentheses or what makes it 0. So we have x plus 6, what makes that 0, and it will be negative 6. We have x plus 1, what makes that 0, and it will be negative 1. So what we're finding is at negative 1 and negative 6, those would be the x-intercepts of the graph. So factored form gives the x-intercepts. Vertex form gives you the vertex of the quadratic. So we're going to practice factoring so that we can find those x-intercepts of the graph. So it says today we'll practice factoring quadratics. Why do we factor? So we can find the x-intercepts. They're also called the zeros of the graph. If I can spell, it's not zeros. They're also called the roots of the graph. So we're finding all of those when we factor. How does factoring work? Well, we want the x-intercepts, and then what is the y value? The x-intercepts is at 0. So again, here's the x-intercepts, y equals 0 there, and so that's what we're looking for. And it says, let's say you had the equation y equals x minus 3 and x plus 2. What x values will give us 0? And it's called using zero product property, because if either one of these is 0, the whole thing is 0, because 0 multiplied to anything is 0. So really, here's what you should be thinking. X minus 3, what makes that equal 0? You would add 3 to each side, and it's just going to be the opposite number, or 3. And for the second factor, we have x plus 2 equals 0. And if we were to solve for that, x would be negative 2. So these are called the zeros of the function. If we were to sketch this, at 3, there would be a 0. And at negative 2, there would be a 0. And then we would draw our graph, our quadratic. So again, our goal today is to factor so that we can find the zeros or the roots. And our goal today is just practice factoring. How can we factor? We can use diamond problems, so we've been practicing those in class. So to make your diamond, the last number goes on top, and then the middle number goes on the bottom. And remember, it's the product, or what multiplies to the top number, that adds, or it's the sum of the bottom number. So let's think of two numbers that multiply to 12, and then we have to find the right combination. So not only does it multiply to 12, it adds to 7. So we have 1 and 12, 2 and 6, 3 and 4. These are all factors of 12. And so we have to pick the combination that also adds to 7. So that would be 3 and 4. So we've been practicing these diamond problems. Most of you are very good at this. So now we will just write the factored form. It's going to be x plus 3, x plus 4. That's the factored form. If I were to ask you to find the zeros or the x-intercepts will be negative 3 and negative 4. So if we were to graph that, at negative 3 there would be a dot, at negative 4 there would be a dot, and you would have your quadratic something like that. All right, let's try the next one. Again, we'll make our diamond. The bottom number goes on top. The middle number next to the x goes on the bottom. And it's what multiplies to 12 that adds to negative 8. So let's think of some factors of 12. So again, we have 1 and 12, 2 and 6, 3 and 4. So we want the combination that not only multiplies to positive 12, it adds to negative 8. And so that will be this combination right here, but we'd have to make them negative. Negative 2 and negative 6 multiply to 12, and they add to negative 8. So then if we write factored form, it would be x minus 2 and x minus 6. And then if I asked you to find the zeros, this is factored form right here, and the zeros would just be the opposite, or what makes it 0. So x would be 2 and x equals 6. If we were to graph it at 2 and at 6, you would have your x-intercepts. And let's take a look at our last one. So again, we'll make our diamond, and it's what multiplies to negative 35 that adds to negative 2. Let's think of some factors of 35, 1 and 35, and probably 5 and 7. So it's this combination, but we have to make one of them negative, so it multiplies to a negative 35 and adds to a negative 2. So that would be a negative 7 and a positive 5, and so factored form for this one would be x minus 7, x plus 5, and the zeros would be 7 and negative 5. And what I mean by zeros are the x-intercepts at negative 5, it would cross. 2, 3, 4, 5. And at 7 it would cross, or a parabola would look something like that. Let's take a look at difference of squares. It says list all the square numbers from 1 to 144. A square number is any number times itself. So 1 squared is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144. So these are all square numbers. So now we're going to factor and look for a pattern. So we have x squared minus 9. So here the bottom, the last number is the negative 9. The number next to the x goes on the bottom, and there's not a number next to the x, so it's 0. So we have two numbers that multiply to negative 9 that add to 0. So that would be a 3 and a negative 3. So factored form looks like this, x plus 3, x minus 3. All right, let's try the next one. Again, a negative 16 would go on the top and a 0 on the bottom. We need two numbers that multiply to negative 16 that add to 0, and that would be 4 and negative 4. And you can write them in either order, x plus 4, x minus 4 could come first, because when you multiply two numbers, it doesn't matter the order. So we have x plus 4, x minus 4, and then we have our last one, which is what multiplies to a negative 4 that adds to a 0, and that would be 2 and negative 2, or negative 2 and 2. Again, doesn't matter the order. So I want you to look for a pattern. What are you noticing about this number and these numbers, this number and these numbers, oopsies, and this number and these numbers? And you can see that if we take the square root of 9, we get 3, plus or minus 3. The square root of 16 is plus or minus 4, and the square root of 4 is plus or minus 2. So if you have difference of squares, so two square numbers that are being subtracted, you can just take the square root of that last number, and it will be your factor. So here's an example. We have all square numbers here being subtracted. What is the square root of 4x squared? And that would be 2x. What's the square root of 1? And that would be 1. So this factored would be 2x plus 1, 2x minus 1. So anytime you have difference of squares, so two square numbers being subtracted, you just take the square root of each one. The square root of x squared is x. You put a plus or minus, you take the square root of the second number, and you have your factors. So there's a shortcut for difference of squares. Now your assignment today will be on Delta Math, and we're going to practice factoring with diamond problems and writing it in factored form. And then we'll go over a new type of factoring tomorrow in class.